Alright, here is a video overview of Learning Targets 1 through 4 from Chapter 4, which is called Atomic Structure and the Periodic Table. This is a very long chapter, so we divide it into two tests. So this is part of the material on the first test. We started out by talking about models and reminded them of the definition of a model. A model is a representation of something that we want to study in science that we can't actually bring into the room, either because it's too big or too small or too expensive or too hard to see or too hard to study. We can make a model of it to study instead. And the first model of the atom that I gave the students was an egg, which is a good model because it has three parts: the yolk, the white, and the shell. Like an atom has three parts: proton, neutron, and electron. Now when the students become chemistry students, when they're junior year, they're actually going to learn about more subatomic particles, but for right now we're just working with those three. An egg is a bad model of an atom because we expect an egg to have one shell and one yolk and one white, and when you have two yolks or two shells, it's considered unusual. That's not true with atoms. We expect atoms to have all different numbers of protons, neutrons, and electrons. So here are some of the things that are happening in this section. We're going to learn about how atoms of one element are all alike, and we're going to learn about different models of the atom. We're going to learn some of the more popular atomic models. We have to start with looking back at the subatomic particles, and this is a review for the students. They learned this in junior high. The three subatomic particles they need to be familiar with are protons, neutrons, and electrons. Protons have a positive charge, electrons have a negative charge, and neutrons are neutral. Protons and neutrons are both located inside the nucleus of an atom, and that's just in the center. And electrons, with the model that we're going to be focusing on, has them circling the nucleus. Here's the symbols that we use: plus sign for protons, an N for neutrons, a negative sign for electrons. The proton is kind of the magic subatomic particle that tells us what the element is. For instance, 8 protons, I know it's oxygen. 11 protons, I know it's sodium. 1 proton, I know it's hydrogen. This table is very important for students just to simply memorize. They should know. I should be able to ask them anything on this chart, and boom, they should know it. I should be able to say, where's the neutron located? What's the charge of a proton? What's the symbol of electron? And boom, boom, boom. They should just have that. Alright, we then talked about three of the more common models of the atom. There's been a lot more over the time, but these are three we focused on. We started with the Democritus model, and students have a handout that had these sections filled in. But Democritus was the first person who really figured out that if you broke any substance into smaller and smaller pieces, that you'd get a smallest unit of that substance. He didn't have any understanding of subatomic particles, but he did know that there had to be a basic unit of gold that was different than a basic unit of silver, that was different from a basic unit of copper. Years go by, we get up to the model of the atom that was called the Bohr model of the atom. This is the one that we'll focus on in this class. This was really put forth in about 1913, and it recognized protons, neutrons, and electrons. And again, the students have a handout with these areas filled in. And it envisioned the protons and neutrons being in the center with the electrons going around in these beautiful little circles, kind of like planets going around the sun. The modern model of the atom, which is more recent, recognizes that the electron's behavior isn't that simple, and that they don't go in these nice little circles, but they exist in areas called electron clouds. And here are some sketches and diagrams of some of those. It's much more complicated than the model we use. Students will need to learn that eventually. They'll learn it when they're juniors in chemistry class. It's harder than we need to learn right now. We want the focus to be on atoms' behavior instead, and so we're going to stick with the Bohr model of the atom because even though it's not quite right and it doesn't truly depict electrons, it's sufficient for us to learn what we need to learn. This is all going to come down to us understanding the periodic table. On the periodic table down here you see the name of the element. Here you see its symbol or its formula, and up here is a number called the atomic number that we're going to talk about shortly. This is the number of protons. So manganese, one manganese atom has 25 protons. One boron atom has 5 protons. We know, of course, that atoms can be broken up. They're made into the subatomic particle. This is a summary of what we talked about before, and we practice this with the students, identifying protons, neutrons, and electrons. And we had a little quick clicker activity that we did on that. And these are the kinds of things students should know. If students want to test themselves on this, you should just pause this video right now. And then I'll give the answer in just a second. What best describes an electron? Electrons are negative. They're outside the nucleus, so the answer would be B. What best describes a proton? Protons are positive. They are inside the nucleus, so the answer would be D. How many protons does chlorine have? To answer this, students would need to look this up on their periodic table, and the answer is 17. What best describes a neutron? Neutrons are neutral, and they are inside the nucleus, so the answer is F. Which subatomic particle tells us what the atom is? And that's C, proton. Which subatomic particle is so small we can ignore its mass? The answer is A, electron. The atomic number is the same number as the number of protons, which I showed you just a few moments ago in the periodic table. Mass number is the number of protons plus the number of neutrons. This number is not found on the periodic table. A similar number is, but not this particular number. So the next thing that we did is we worked with atomic numbers and mass numbers and calculating those. A couple little rules to make this pretty straightforward. If you add together the number of protons and the number of neutrons, you get the mass number. The number of protons is the atomic number, and for right now, the number of protons is equal to the number of electrons. So we worked on some things like this. We went through a worksheet on this. If I tell you any two of these, you can figure out the rest. So if I tell you the atomic number, let's say that we have an atomic number of 12, and let's say that we have mass number of 20. That means we have 12 protons, we have 12 electrons, and our number of neutrons plus our number of protons is going to equal 20. So at that point the students ask themselves, okay, what do I have to add to 12 to get 20? And that will be their number of neutrons. So 8 neutrons plus 12 protons would give a mass number of 20. And different ways I could ask this. I could use symbols instead of writing out the words protons and neutrons. And this is a important basic skills for the students to be good at, and again they have a worksheet on this in their folders. If an atom has 12 protons and 9 neutrons, what's its atomic number? So this is another example of the kind of problem students should be able to answer, and again I'm going to wait just a moment and go over the answer. So students, if you want to practice this, you can just pause. The answer would be 12, because the atomic number is the same as the number of protons. How many neutrons does it have? Its mass number is 12. It has 5 protons. So 5 plus what gives us 12? So the answer is 7 neutrons. If an atom has a mass number of 32 and 15 protons, how many electrons does it have? 15, because the number of protons and electrons are the same. If an atom has 10 protons and 8 neutrons, how many electrons does it have? 10 electrons. If an atom of chlorine has a mass number of 30, how many neutrons does it have? Well, students would have to look up on the periodic table the atomic number of chlorine, which is 17. The difference between the mass number and the atomic number, so 30 minus 17, would tell us how many neutrons. And so forth. Alright, now, at this point we start to focus on the Bohr model of the atom. We're talking about the electrons here. It's important that students keep in mind we're talking about electrons. The electrons are going to, in this model, orbit the nucleus in what we call energy levels, and sometimes called shells. For right now, the first level can hold 2 electrons, the second, the third, and all the subsequent can hold 8. Now again, we're using a model of the atom here that's not the most modern model. We're even using a simplified model of that. So this isn't actually true. The electron levels are much more complicated than this, but this is a simplified version that will allow us to work with the students to identify electron positioning and the behavior of different elements. Valence electrons are the electrons that are on the energy level the farthest away from the nucleus. Valence electrons are very important because they determine an atom's chemical properties and its ability to form bonds. So, for instance, if an atom has, let's say, 5 protons, so 1, 2, 3, 4, 5. We're going to not talk about the neutrons right now simply because we don't need to. It's not critical to this particular step, but keep in mind that this would also have neutrons in it. The number of neutrons will be based on the isotope of the atom, which is in the next set of learning targets. So our number of electrons should match our number of protons, such that we have 5 electrons. Our first energy level holds 2 electrons. Well, that's 2, but we have to get that all the way up to 5, so we need 3 more, so we need to go to the next level. Oops, sorry, put that in the wrong place. We want an electron there. Here's 1. Here's 1 more. And here's 1 more. So now we have 5 electrons and 5 protons. And the outside level of the atom, so the level that's farthest away from the nucleus, which is this one, has 3 electrons. So we would say that it has 3 valence electrons. Alright, well, let's say that it's got more. Let's say that we've got, say, 11 protons. So let's ramp this up a little bit. Now I've got 11 protons, so we need a total of 11 electrons. So let's fill these up. Alright, that gets us up to 10, which is not enough. We need 1 more, so we go to the next level. Well, now we've been working with 3 energy levels, and we have 1 valence electron because the outside level has got 1 electron in it. So this particular atom, which happens to be sodium, has 1 valence electron. We're spending several days working on this. This is an important skill for the students to be able to do. If they already understand what's the charge of a proton and where it is, and what's the charge of an electron and where it is, and that protons and electrons are going to, for now, have the same number, this isn't particularly hard. If they haven't learned those things yet, this is going to be really a struggle. That's why it's important for students to keep up on a daily basis in this chapter. And students will be freehanding these. So again, let's say that we have 12 protons. So let's drag some electrons in. There's 2 on the first level. There's up to 8 on the second level. By the way, I'm not picky about where these electrons go on this level. It's good habit to draw them in pairs, but I won't be any pickier than that. Well, that gets us up to 2 plus 8. That gets us up to 10. We need 2 more electrons. Again, it's not really important where you put them as long as they're on the right level. I'm okay if students put them like that. I'm okay if students put 1 there and 1 there. But it is good habit to keep them in pairs on the 4 sides of the circles. Okay, there we have, we've got 12 electrons. 2 of them are valence electrons because they're on this outside level. So we would say that this particular atom, which is magnesium, has 2 valence electrons. And these are the kinds of questions that students should be able to answer. Draw a Bohr diagram for beryllium. How many energy levels does it have? I'm going to skip through these quickly because we haven't done these yet in class. These would be good for students to practice later. Oh, this is a good one. What are the dashes that you draw in the circles on a Bohr diagram? Those are electrons. Students need to keep that in mind. They're not just little dashes. They actually are a subatomic particle. Where's all this going? Well, this is going to tie directly into the periodic table, and students are going to learn some pretty neat things about why the periodic table is shaped the way it is, having to do with energy levels and valence electrons.